Okay, today we're going to work on formalizing our problems. We have been spending a lot of time learning how to set up equations and solve them for geometric pictures. And now we're going to figure out why is it we can do that. So before we do, we need to review some properties. And so you have been given a handout that looks like this: Basic Properties of Algebra. And at the top we have mostly properties that deal with operations: add, subtract, multiply, and divide. And then we have a few that deal with the fact that you might have things that you can put in a little different order and it still means the same thing, with reflexive, symmetric, and transitive. Then we have substitution. There are two kinds of substitution. You can take this letter out and put this number in for it, and that shows right here. Or you can have an expression, do part of it, like 7 plus 3 makes 10, and replace the problem piece with the answer. That's two different types of substitution. Then we also have some that deal with geometry as well. But our most familiar one is distributive property. And distributive property is just multiplying through the parentheses. Now we also have properties of congruence that deal with the actual shapes. For example, if you had a picture of two triangles that were side by side and they shared this side from A to B, then it makes sense that AB would be equal to AB because that is a segment on both pictures, but they just happens to be the same segment. We also understand symmetric means turn it around. So if we look at AB is congruent to CD, we know we can turn that around. It means the same thing. Or even with the angles, AB is congruent to angle A is congruent to angle B. Now transitive is a little different. Transitive, what you end up having is you have these two in the middle that happen to be the same segment. So if you know AB is congruent to CD and that CD is equal to EF, then it's just a logical conclusion that AB would be equal to EF because they're both equal to the same thing. That's like saying AB is equal to 7 and 7 is equal to EF. Well, if they're both equal to 7, then they obviously are equal to each other. And you can do that with angles or segments, and that's called the transitive property. So what I want to do next is look at a few examples of properties and see if we can pick out the correct property. So looking at your worksheet, what you need to be able to do, and you should print this worksheet down with those properties on it that's not on Canvas, so that you can have that next to you. If you have not, pause the video, print that, or bring it up on your screen so you at least can scroll through it and look for these properties. Now, what you want to do is look for the change between the if part of the problem to the then part. So I know when I solve this first problem, I'm going to take 9 away. And that when I take 9 away, I end up getting 2x equals 10 because 19 minus 9 is 10. But when I name the property, I have to think about what operation I just did. I did subtraction, and that is the name of the property. The subtraction property of an equality. So we abbreviate property of equality. Now in this next one, we've got O is equal to congruent to W, and angle W is congruent to angle L. And see, they both are congruent to W. That's again that property that allows us to see that we can take out the middleman and put in, and for some reason my marker's not working, so let me try that again. Take out the middleman and just have that AB is congruent to EF like before, that transitive property, and that's what's here. If I take out these two that are alike, then I have angle O is equal to angle L. So here we have transitive. And I think we'll just abbreviate that. In number 3, we have the measure of angle E is equal to the measure of angle T, and I turned that around and put T first, because sometimes it might be important to turn something around. When I look at these properties, I see that one that allows me to turn these two around is symmetric. Now, in number 4, you have angle K is congruent to angle K. When we go back and look at our congruencies, we see that's the reflexive property. I do not know why it keeps doing that. There we go. It's right now. Reflexive property. And in this last one, if you look at the if part, you obviously want to get rid of the subtract 8, so you would add 8 to both sides. And this clearly is how they got that 18. So this is the addition property of equality. So that's kind of one of the things you need to be able to do. You need to be able to pick out the correct property because you're going to have to write down those property names. So let's look at how that just works with a problem that you're just going to work out a very short little problem. Well, we do what we call a proof. And a proof has 2 columns. The first one is for statements. And the second one is for reasons. Statements are the math you're showing. So first I'm going to start off with the problem. 1/2 x minus 5 equals 10. That is our given. So the reason is given. You got to have something to get started with these problems. So the first one is always going to be your given. Whatever they say in the problem is given, you write that down, and that's your first line. Now, what am I going to do to fix that problem? Well, I'm going to add 5. And what property says I can do that is addition property of equality, because it allows me to add 5 to both sides to solve the question. So that leaves me with 1/2 equals 15. Now I just added the 5 and the 10 together to get that 15 and dropped out the 5s. So I took out a math problem and I put in the answer. That's when you use substitution. Substitution allows you to take out a larger part of the problem and put in the answer to that problem. Now in the next part, I left my x out of there. I need that x because I got to see that that x is multiplied times 1/2. Now normally when we think about multiplying, we think about dividing, but I can't divide in this problem because I don't know how to divide by fractions. So in step 4, I show how to flip and multiply. Now notice I'm doing that as a separate step because I can't write that on top of step 3. It already has a reason. So I have to show a totally separate step to show that multiplying to both sides. And that is the multiplication property of equality. In number 5, these 2's will cancel, so I'll have x equals, and I'm going to multiply this together to get the answer, which is 30. And that's substitution, because every time you do something that says an operation, like I say I'm going to add, I say I'm going to subtract, you have to substitute the answer in from what you get from adding or subtracting. So I multiplied 5 times 15, so I've got to put in the answer 30. The question asks me to prove what is x equal to. I have proven that. I have shown all the work and the reasons for that work to get the answer x equals 30. So this is more like an algebra proof because it's showing you how to do the math, but at the same time it's justifying it with those properties. So let's see how that works with some pictures. So here in this, we're going to work a few with segments first. So here in the segment problem, I have 2 segments, obviously not of equal length. And AB is equal to 3y minus 9, and 2y is what BC is. But the given in this problem says from A all the way to C, and that's something sometimes you might want to mark on your picture. All the way over here is 21. So when I put the 2 of them together, I get 21. So to get this problem started, again, you make 2 columns. I typically find that I make the statement side a little bit bigger than the other side just so I have room to show math. And my reason side, it's just writing out the name of the property, so it doesn't need to be quite as large. Let's start with that given. AC equals 21. So there's our given. We've listed that. So let's think about if we weren't doing a proof, what would we do with this? Well, we've been studying that, we have problems that are equal to each other. They add up to 90, they add up to 180. We have the segment and angle addition rules that say that you can add two segments together and it's equal to a larger segment. Or we have angle bisector and midpoint that cuts it in half, so we set them equal. We have lots of different rules we've been studying. This rule happens to be that I want to put two segments together and make a larger segment out of it. So first we're going to state the names of the segments that we're adding. So the first segment is AB, and we would like to add BC to that. And when I put those two segments together, it makes AC. This is segment addition. Because I'm adding two segments together and getting a larger segment. Now once you state that, then you can plug in what those represent. On the picture, AB says it's 3y minus 9. On the picture it says 2y for BC. And in our given, it said that AC is 21. So we have now substituted all of the different things that are on the picture as well as the given into our formula. So in step 4, we're going to continue looking at this from the perspective of the same thing we've been doing already. Do I have two items on this side of the problem? No, I have 3. Do I have any like terms? Yes, I have two variable terms, 3y and positive 2y. That makes 5y. So I bring the minus 9 down and say 21. I put two things together and replaced it with 5y. It's like taking two guys out of the basketball game and putting one guy in to replace him. So that's substitution. So as you can see, there are two different kinds of substitution. Replacing what it means and doing some math and replacing it. So now in step number 5, we need to finish solving this two-step equation that we're very familiar with. We know that we got to do the opposite of the one that doesn't have the letter first. So we're going to add 9. And that makes it addition property of equality because we're adding. And then we add that up. And that allows us to say 5y equals 30. That's substitution. And then we want to show the opposite of multiplying here times this 5 is dividing. So that will be step 7, shows division. So last but not least, those y's, the 5's cancel out on that y, and 30 divided by 5 is 6. And I substitute the answer in because 30 divided by 5 is 6. Now the question didn't ask me to find what y is. The question asked to find AB. And we know that we take that and plug it in the expression that they've given us for AB. So let's show how to get that kind of work now. So we're going to first set it up. AB is equal to 3y minus 9. That is what was given to us on the picture. So sometimes you can have a given further down the proof if it's something that's coming off the picture to help you to calculate it. Then we can plug in the number that we got, 6. That's substitution because we took out the letter for y and we put in the 6. And that allows us to be able to calculate this. So in our last statement, AB is going to be equal to whatever 3 times 6 minus 9 is. And we're going to substitute that answer in. So 3 times 6 is 18. Minus 9 is 9, and we substituted in the answer 9. So that's how you show that last little bit once you get your variable on how to find the actual length of AB. Now, we have quite a few examples of this, so I'd like to continue on and look at another example of segments. And in this is where we're going to look at midpoint. We know midpoint means it's in the middle. So we know that when we want to set this problem up, that this segment is equal to this segment, that AB is equal to BC. So we'll start off with our same thought as we did before. And sometimes you don't really have to write those words, statement and reason at the top every time. I mean, if you know that's what goes up there is what you're putting in those columns, just make the T. And you don't have to make it even either. So that's why mine looks a little lopsided. I like to have my statement side a lot bigger. So midpoint of AC. So there's our given. Then, after we state our given, whatever that given is telling us, it usually helps us to find something about an equation. We know that if B's in the middle, those two pieces are equal. So AB is equal to BC. Now, when you have a word like midpoint in your given, then the very next thing you set up about that statement should be the definition of that word. So the reason I can say this is because this is the definition of midpoint. It states that if that letter is in the middle, it makes two equal pieces. And so that's why I can set these equal, because the definition of midpoint says I can, and that was the word that I had in my given. Now, once we have set up our equation, then we can plug in what each piece of our equation represents. So AB is 4x, and BC is 2x plus 20, and I have substituted in what those letters represent, so that's the substitution property. And then I just start solving. Regular old everyday solving equations. So I know that I only have two terms on one side and one on the other, but the x's aren't all on one side. So let's subtract 2x from both sides. So I'm using the subtraction property of equality so that I can subtract 2x and get 2x equals 20. Now I have done 4 minus 2 is 2, so I have substituted my answer in for what I get from subtracting. So every time you have the word add, subtract, multiply, or divide, if you're showing that adding and subtracting, you're going to have to say you substituted in the answer. So I only see multiplication left, so I divide by 2, use the division property of equality, and when I divide that out, I'm going to get x equals 10, and I substitute in the answer. Okay, let's look at our next problem. Our last problem on segments is a little bit different from the previous two because they've already given me the equation to set up. They've already said what the equation is 4AB equals XY. They've given us on the picture what those stand for, and they've asked us to prove what XY is equal to. And in this particular problem, 4AB means that the length of AB should fit on there 4 times. So obviously my picture is not drawn to scale. Let me kind of make that a little bit more drawn to scale. So what they're saying is I could put 4 of these across here. Does that make sense? Well, let's see. Whoop, got to lay the marker down. Now, as you can see, I could get 4 of them across there. And that's what it means, that it takes 4 of that smaller one to make the bigger one. But in order to make it to where you can see it, I had to make it enlarged so you could read it. Because if I'd have made it that small, you might not could read the 2x minus 3. So I'm just going to pull that back out so we can see it better. So our picture's not drawn to scale that way is what I'm trying to get to. Alright, so in our proof we start off with our given 4AB equals XY is the given. And since it's already set up an equation, we can go straight to plugging in that AB is 2x minus 3. Notice I put parentheses around that so I can show I want to multiply 4 times the whole entire item that represents AB. And that XY is 2x plus 36. So that is substitution. Because we have just replaced all the letters that represent segments with what they represent in lengthwise. Now, in that particular case, we know that when we see this, we have variables and constants on both sides, but we have parentheses on one side. So let's distribute that out. 4 times 2 and 4 times 3. 8x minus 12 will make that a whole lot easier to work with without the parentheses on it. So we distribute it. So that's what the property name is. See, a lot of times the property name is what you're doing. You're substituting, you're subtracting, you're dividing, you're distributing. Now, I only have 2 items on each side. One has an X on it and one doesn't. So therefore, adding like terms will not be needed in this step. But what I do need is all my X's on the left. So I'm going to take 2x away from both sides. So I'm using subtraction. And that's the property of equality. So make sure you put that on there. So you can definitely make sure that looks a lot different from substitution, because we abbreviate substitution different. But it looks even more different because it's longer. Now we've got 8x minus 2 is 6x. We have this minus 12, and these dropped out, so that left me with 36, and that's substitution because we replace the x with what it represents after you subtract them. That 8 minus 2 is 6, and we substitute in that answer. Now we're down to that two-stepper, that same thing we keep looking at all the time. So we have plus 12 on each side. That's step number 6, and that means we're adding. The addition property of equality says we can add to both sides. 6x equals 36 and 12 make 48. I substituted in the answer. So every time you use the word add, subtract, multiply, or divide, you see in every one of these proofs I work, I've substituted in the answer. And then last but not least, we're going to divide by 6. So that's the division property of equality. And we just used division, so we've got to put in the answer. 48 divided by 6 is 8. So we have substituted in the answer. So as you can see, every time I said division, I said substitution. Adding said substitution. Subtracting said substitution. We always substitute right after we add, subtract, multiply, or divide. So these are your examples for segments. You probably should stop the video at this point and go to the classwork and do the first part of the assignment. I hope that you stopped the video after the ones we did with properties, but if you didn't, stop now, and that probably will get you down further on the classwork to be able to maybe state a few properties and then work the questions that relate to segments. When you have finished that, then you can come back to the video and watch some on angles. So stop the video now. Well, since you have done some classwork on that, let's go into angles and see how do we prove angle problems. What rules do we use? How do we go about that? So in this example, again, we're making our T-chart here for our 2-column proof. And the given here is a little long, so you may have to make it wrap a little bit because it's kind of hard to get all of that on one line. And that's okay if you have to make it wrap. I'm going to abbreviate supplementary angles, though, because that way I can make sure I can get it on there. So it says given the AOM and MOC are supplementary angles. So I wrote my given. And you don't have to number on both sides, but some people do, especially sometimes when they have that 2-row thought, so to make sure they understand that the next one is not, this is not number 2, that this is number 2. Now, what does supplementary mean? Look at your picture. What does it mean if those 2 angles side by side? Right, they're on a straight line. They make an actual 180 degrees. So the measure of angle AOM plus the measure of angle MOC is equal to 180. We know that because we've been doing that. We've added 2 angles together and get 180. We've added 2 angles together to get 90 for complementary. So we can set that statement up because the given told us it did. You see, the given has the word supplementary in it. And supplementary's definition is it adds up to 180. And that's the rule. Every time you see a word That's the rule that you need to put over here. So since the definition of supplementary angles states that two angles add up to 180, that word up there gives you away the reason for number 2. Now in number 3, we have our equation set up with letters that represent the names of the angles, but let's find out what the expressions for those are. From A to O to M is our larger angle, 2x plus 30. And M to O to C is our smaller one, x. And that has to make 180. So we have substituted in what the picture says that they represent. Now once we substitute, we start thinking about solving equations. In solving equations, you can't have but 2 items on the left side or the right side, and here in this problem I have 3. I have an x term and another x term that maybe we should put together, those like terms. So 1x and 2x make 3x. I still have that 30 that's a constant that doesn't have a letter, and I still have the 180 on the other side. We just replaced the 2 x terms with the answer. So that's substitution, because you can take out part of the problem and replace it with something you've done, like adding or subtracting like terms. Now, we've got it down to that 2-step method now that we're so familiar with. So we always get rid of the one that doesn't have the letter first. So we subtract 30. That means we've used the subtraction property of equality, because we're using subtraction to solve. So that'll be 3x equals 180 minus 30 is 150. And we just substituted the answer. Remember, every time you use an operational word, then you have got to say you substitute to get the answer. So now, since I only see multiplying here between the 3 and the x, I'm going to divide by 3 in step 7. Division property of equality, and actually physically divide it out and put the answer in. 150 divided by 3 is 50, and I have substituted. Now I'm not sure if I was looking for x or if I need to go further, so let's go back up and look at our proof. No, prove x equals a question mark. So in that case, this is what I was looking for, and so I can stop. If I had asked you to find one of the angles, then I'd need to plug in the 50 for x, and that would just take a few more steps. I'm sure one of our other examples will ask us to do that, so you can see that another time. So in this question, we're looking at 2 angles are bisected, meaning that they make 2 equal angles, and we are used to that already because we have done quite a few problems that do that. So let's state our given. AB, the ray, bisects angle RAN, our given. So we know when you bisect an angle, it makes 2 equal angles. So we're saying angle RAB, and that's the measure, so don't forget to put that little m in front of it, is equal to the measure of angle BAN. And the reason they're equal is because they've been bisected. And the word bisect is a verb that represents one of our vocabulary words. We're bisecting angles, so this is angle bisector. And actually, it's the definition of angle bisector. So let me fill that in. Definition of angle bisector. So then, once you set up your equation of angle bisector, then you're looking at filling it in. So x equals 2x minus 75 is our equation, and we've just substituted in our answer. Oh, not our answer, but excuse me, our expressions for RB and BAN. Now, let's look at our solving. In this problem, we only have an x on the left, but on the right we have 2x minus 75. And on the right are only supposed to be numbers without letters. So how do we get this 2x over here? Is subtraction. Because it's positive right now, so we need to subtract to get it to the other side. So that's the property, subtraction property of equality. Now, once you do your subtraction, you may find it helpful to put this 1 in front of that x, so you can do 1 minus 2. That comes out negative 1x, and I bring down the negative 75. I've replaced the first column with that answer, so I have substituted in the answer to replace the two terms of x. So, to finish this question, I see that this x term over here has a negative 1 in front of it. So let's divide by negative 1 for step 6. That's division property of equality. And substitute in the answer for what that would represent. So in number 7, x equals 75. So we have solved our problem, but then we look back up here and we go, well, gosh, I'm not just supposed to stop there. I'm supposed to find the measure of angle BAN. So in order to find that measure of angle BAN, first let's talk about what is BAN. Well, BAN was the bottom angle, 2x minus 75. So that was given to us on the picture. So we are going to plug in what we found x to represent. BAN equals 2 times 75 minus 75. We're replacing the x with the answer for what x came out to be. So that is substitution. And then we actually evaluate that. Whatever 2 times 75 minus 75 is, we're going to replace that with the answer, which happens to be 75, because if you have two 75s and you take one of them away, you got 75 left. You can do the math on the calculator as well. So I substitute that in, and I find out my problem is 75 degrees. I think we have one more proof problem to look at. And this one is more related to what we looked at before, where you put two angles together and find the total. So let's start off with our given. Number 1 is the measure of angle AOC equals 139. That is our given. But we can see AOC is made up of two angles. The measure of angle AOB is the top angle, and we're going to add that to the measure of angle BOC, because that makes the whole entire angle the measure of angle AOC. When you add two angles together to get a bigger angle, that's angle addition. So in our next statement, we can plug in what our angle addition problem set up. So x is the first angle, 2x plus 10 represents the second angle, so we're just taking those out and putting in what they represent. And the first statement told us that the third angle is 139. That is substitution. So in step 4, you just start solving. I see I have way too many terms over here, so how about we put our like terms together? We have an x and a 2x, so that's 3x. So we substituted in the answer for adding up our x's. Now we need to get all of our numbers to the other side. I see I have a 10 on the wrong side, so let's subtract 10 for step 5. That would be subtraction property of equality. And that will give me 3x equals 129. And that is substitution because we've put in the answer for what 139 minus 10 is. Now we know we divide to get rid of multiplying, so let's divide by 3. Division property of equality. And show the answer for dividing by 3. X equals 43. Because 3 goes into 12 4 times, and 3 goes into 9 3 times. So that's how we got that answer, or you can just divide it on the calculator. And since the proof statement says find what x is equal to, and I have found that, I have completed that question. So our last proof is for right angles. Why don't you try that one yourself and see how it works and come back and check it. Okay, so in this proof we stated the given that angle AOC is a right angle. So that tells us that in the definition of the right angle that the angle is 90 degrees. But we also have a picture in which has two angles inside of that 90-degree angle. We have these two parts. So we want to add those together and make the whole angle. So that's what I did in the next part. And there looks to seem to be a little bit of problem with letters in this. I think there's a typo. There's supposed to be a D in this first angle. Looks like an O instead of a D. So angle ADB and angle BDC have to be the whole entire thing ADC. So then you substitute in what they represent off the picture. So 3x minus 10 plus x equals 90 is what I got from taking the two pieces off the picture and setting it up equal to 90. So once I've done that, once I've set up that, I can go through the whole problem, put my x's together. I see here I have an x and a 3x that make 4x. That turns it into one of those two steps. Then I saw I have subtraction of one that doesn't have a letter. So I added to both sides and got 100. Then of course the last step is always division. Now if you've gotten your 25 correct, then this shows you how to finish the problem. You go back and pull the information you needed to set up the question. I see I've reversed a couple of letters here, so let me fix that. The picture doesn't have an ABD, it has an ADB. And then once you find that equation, you plug in this 25 for the x. So 3 times 25 minus 10 equals 65. So in that particular case, I found the angle that I wanted to know was 65. When I look at that picture, that makes sense that ADB would be 65 because it is a very large angle compared to the other one. But the other one was 25. So if I label my picture with that this one is 65 and this one is 25, they should make 90 together because they should make a right angle, which they do. It adds up to 90. So that's your check to make sure you've done it right. So now it's time for you to do your classwork.